All right, so we have a position time equation for a mass that's oscillating. Probably what you've got going on here is you've got a spring hooked up and a mass is going back and forth. Maybe we stretch it and it goes back and forth and back and forth. We're trying to find the amplitude, but we have the equation. So let's think about this here. The equation is x is equal to 2.1 centimeter times cosine of 12t. Now, what I like to think of it is this way. The way I like to write out the equation is sort of the master equation. The x of t would be equal to a, amplitude, times the cosine of 2 pi ft. Or sometimes we can say that's equal to a cosine of the angular velocity times t, because 2 pi f is equal to w. So in the first case, we're trying to find what is the amplitude. Well, you're going to solve for a. Well, actually, a is there, right? And if you want to determine the period, you know what a is. How to do the period? The period, I use the equation is period. I mean, period is, I think I solve for frequency, yeah. So if I solve for frequency, once you know the amplitude, well, we know it, I want to solve for this right here. Yeah, 12 is 2 pi f, right? So if 12 is equal to 2 pi f, I can solve for f. Now, frequency and period are not the same. They're the inverse of each other. So once you know f, of course, t is equal to 1 over f, and so you could then solve for the t, capital T period, right? And if you want to determine the spring constant, so for the spring constant, we're going to use the equation. So again, it's really kind of knowing which equation to use. So the spring constant, t, of course, is 2 pi square root of k over m. Now we know the t that we got from here, 2 pi k. All right, what's k? K, you're trying to solve for k, and you know the mass. At some point they gave us the mass. What did it say? This is 51 grams, so, or 0.051 kilograms, and then you can solve for k. Find the total energy. Now, the total energy is a little tricky because what it is, the total energy equation is E, or the total kinetic energy, is 1/2 mv max squared. So we need to first find the V max. Okay, again, another equation. Look at your equation sheet. V max is 2 pi f a. You know all of them, 2 pi and f and a. Well, 2 pi f is 12. So it's 12 times 2.1, actually. That's your a, or make it to meters. That gives you your max speed, and you can do 1/2 mv squared. So done for that one. And lastly, what is the velocity at t equal to 0.41 seconds? So I then take this equation. No, I don't use this equation, pardon me. One more equation. There is also, look at your equations, you can also write the v in respect to t is equal to negative v max, so the number you find here will be used here, times the sine of 2 pi f t. So the t is now 0.41. 2 pi f is 12. The max speed you found here, and you can find the velocity. Okay? And don't panic. I think the velocity answer here will be negative. You can't have a negative speed because it's going back and forth, and at that particular time it might be moving in the negative direction.